Hey there, everybody, and welcome back to another college algebra video. We're talking about logarithms, the properties of logarithms. I mentioned before that logarithms are not like regular numbers. They're not like regular functions. They have their own specific rules, and if you know the rules, then you're good. You just don't want to apply non-logarithm rules to logarithms and vice versa. So we've got three rules: product, quotient, and power rule. We're going to practice those by expanding logarithmic expressions and also condensing them. And then we're not going to worry about the change of base property. Most students have a base thing on their calculator as it is. And if you don't, then you'll be able to get away with using the base of 10 or the base of e for application problems in the future. So we're not going to worry about that. Okay? So the product rule states that if you have the logarithm base b of a product of two things, you add the logarithms. Now, where does this come from? This comes from the fact that if you multiply a to the m times a to the n, two exponentials, what do you do with the powers? You add them, and remember where logarithms come from. They're powers, right? They come from the inverse of the exponential. So it makes sense that you would have a product goes to addition, okay? Notice that there are two things that change, right? What changes? We change from times to plus, and we also change from one logarithm to two logarithms. Okay, so because they're rewriting something, we need to be able to balance that out, and typically balance requires two things. You add 4 to both sides, one side then the other side. That's two things, right? And so students often confuse these rules, and the mistake that they make is they will take one logarithm to 1, or they'll take two logarithms to 2. That never happens for the product or the quotient rule. Okay, the power rule is a little bit different, but you'll get that too. So let's put the product rule into use. We're going to take log base 6 of 7 times 11. What can you do there? You can write that as log base 6 of 7 plus log base 6 of 11. Now, that probably doesn't look necessarily any better. And I don't know that it is. It depends on your context. But let's take a look at the second one. This is 100 times x as a product, right? And so we get log base 10 of 100 plus log base 10 of x. Now, how is this better? This is better because log base 10 of 100 is something that we know. What is the log base 10 of 100? Well, what power of 10 gives you 100, the second power? And so this can be further simplified into 2 log x. So now you could see, oh, okay, well, maybe I can see why we might want to expand it out a little bit so we can simplify parts of it. Okay, so similarly, the quotient rule states that if you have one logarithm of a fraction, you get the 2 logarithms, log of the top minus the log of the bottom. And again, this corresponds to your exponential rule that says when you're dividing exponential expressions, that if they have the same base, you subtract the exponents top minus bottom, right? So again, this is exactly the same rule. Same thing here. We have two things that change. The first thing is the divide becomes a minus, and the second thing is you get one logarithm goes to 2 logarithms. Okay, so you do have two changes that balance. What does this look like? Log base 8 of 23 over x. You would simply write log is equal to log base 8 of 23 minus log base 8 of x. And of course, all these rules apply to our two special logarithms, log base 10 and log base e, or ln. So this is what ln of e to the 5th minus ln of 11. And once again, we see here, what is this? ln is log base e. This is the inverse property where you have log base e and e to a power. What do you get? You just get the power, right? What power of e gives you e to the 5th? 5. And then, of course, natural log of 11. We could plug that in our calculator, but unless they ask us for a rounded off answer, or unless it's a word problem, we want to give the exact answer, which is 5 minus natural log of 11. Okay? So that's the quotient rule. The power rule is the third one, and it's a little bit different. You go from one log to one log, But that's okay, because when you have a power raised to a power, what do you do with the powers? You multiply them. So here we think of this as one power, and p is the second power, right? P is obviously in the exponent, but remember logarithm is also a power. That's where it came from. So you just multiply the two powers together. Okay, this is a very powerful rule, no pun intended. The power rule is very powerful because if you have something like log base 2 raised to the x power, then what can you do with that x? You can bring that x down in front, and now I can solve for x here, where x up here in the exponent I can't get to, x down here I can. So this is a very important rule for us moving forward. Okay, so to take a look at what it looks like, you have log base 6 of 3 to the 9th power. You simply bring the 9 down in front. Okay, and that's all you can do in this case. Now what about natural log of the cube root of x? There's no square root property, there's no cube root property, but we can always write roots as powers, right? So the cube root is the same as the 1/3 power, and now we can apply the power rule and put the 1/3 out front. And finally, if there's a group here, it doesn't matter if there's a group or not, there's still a 2 up top, and so this is 2 times log of the group x plus 4. The x plus 4 cannot be broken up. There is no sum rule. There's a power rule that gives you 2 added together. There's a quotient rule that gives you 2 subtracted from each other, but there is no log of sum or log of difference. You cannot distribute log. That doesn't work. That's a rule for numbers. That's not a rule for functions. Okay, and it's definitely not a rule for exponents. So you've got to keep this together. This is the best you can do. All right. So just to summarize, and you probably want to put these down somewhere on a flashcard or something in your notes, product, quotient, and power rule. These are the 3 rules we're going to need. So let's put them together. We want to expand this logarithm as much as possible. Expand, the terminology there simply means that we don't want any products, no quotients, and no powers other than 1. We have 3 rules: product rule, quotient rule, and power rule. So when we expand, we want to use any of those rules that apply until we get it completely broken apart into sums and differences. All right, the first thing I need to recognize is I cannot leave this as the cube root of y. I need to rewrite this as log base b of x to the 4th y to the 1/3. Okay, and then now what do? Now I can do the product rule. Okay, so I do log base b of x to the 4th plus log base b of y to the 1/3. And then after that, I'm going to apply the power rule. I'm going to bring my 4 down. 4 log base b of x plus 1/3 log base b of y. And that is fully expanded. No products, no quotients, no powers other than 1. Okay? So pause the video now and you guys try example 2. Very similar. Be careful, but a very similar problem. Give it a shot. Expand and simplify as much as you can. Okay, so just like in the first problem, we have log base 4, and we're going to have to rewrite the denominator as 16y to the 1/2. But now, you got to be really careful. This is all a denominator. This is all the numerator. And so we use the quotient rule first to break up and get log of the numerator minus log of the denominator, the entire denominator. And then the denominator is a product. So we have to do the product rule. But the product rule states that you get a sum. And if this is what I'm subtracting, then I have to subtract the entire sum. Log base 4 of 16 plus log base 4 of y to the 1/2. The grouping is necessary here. And then we can bring down the powers. 3 log base 4 of x. I'm going to distribute the negative, subtracting log base 4 of 16, and then minus, bring down the 1/2, log base 4 of y. Okay, and now we have one more step we could do. Log base 4 of 16. What power of 4 gives you 16? 2. 4 squared is 16. And so we end up with log base 4 of x minus 2 minus 1/2 log base 4 of y. And that is fully expanded. Simplifying the log base 4 of 16 is an extra step. And that's the way you do it. Okay? So, you need to practice expanding and contracting. This is like calisthenics, like you're going to the gym and working out. Okay? We're going to lift. And the negative is just important as the positive when you're lifting. And so the other direction for your product rule, quotient rule, and power rule is what we know as condensing logarithms. We go from multiple logarithms and logarithms with numbers out front up to single logarithms. And so the process is the exact opposite. We're going to put together, in this case, the quotient log of 7x plus 6 over x, right? And you could simplify the fraction if you really wanted to inside. I would take either one, break up the fraction, right? Either of these is fine. Neither of those is better than the other. They're fine. But this one, be careful. The power rule almost always comes first. If you go back and look at these rules, there's no numbers in front of these guys. So you can't use the product rule or the quotient rule when there's numbers out front. So if there are numbers out front, the first step always has to be bring up the power. Natural log of x squared plus natural log of x plus 5, the group, to the 1/3. You can leave it as 1/3. If you want to write it as a cube root, that's great, but you don't have to. And now you can add, which means I'm going to do the product. Natural log of x squared times the group x plus 5 to the 1/3. And again, if you rewrote that as cube root of x plus 5, I'd be fine. Okay, so that's how you kind of put those together. But again, most of the time, if you've got numbers out front, the power rule needs to happen first. Just like back here, the power rule almost always happened last. Okay, so we're doing things in reverse order. Pause the video, take a look at example number 2. Once again, be careful with your process. Do one step at a time and see what you get. Okay, so to write this as a single logarithm, we're going to do what? We're going to raise x to the 3rd power and y to the 4th power and z to the 5th power. And now we combine these two guys using the quotient rule. We get the natural log of x to the 3rd over y to the 4th. And then we're supposed to also do a quotient here. So if we do a quotient here, notice the algebra. We get x to the 3rd over y to the 4th all over z to the 5th. But that could be simplified. I don't want a complex fraction. Think of this as over 1. Keep, change, flip. You get x to the 3rd on top and the y to the 4th and z to the 5th are both in the denominator. Okay, so there's a little bit of algebra that goes on here to get from here to here, but this is condensed and simplified. You can't give me a condensed answer that is a complex fraction. I don't want that, right? So you need to simplify it all the way down. Okay, so section 3 is all about getting these rules down, even though you can look at the 3 rules on a piece of paper. You need to have them down like the back of your hand. You need to know how to use them. It's one. I don't care if you memorize the rules. What I care is that you can use them efficiently and consistently. And so that's what we're doing. We're stretching, expanding, and then we're condensing. We're expanding, condensing, and just do a whole bunch of those problems. You got plenty of problems in my math lab. Also, you've got plenty of problems on worksheets. So take your time, go one step at a time, and you should be good. All right? See you later. Thanks.